Thank you. Hi, I'm Ramona Marfievich. I'm lead IoT engineer at Digital Catapult. And this panel entitled Security Challenges for Hardware and IoT Makers is going to discuss the current state of hardware security, if there is a current state, as we discussed before, the most pressing threats on the hardware side, and approaches to secure it. And for this, we brought in front of you 3 awesome panelists. I'm just going to tell their names, and then I'm going to let them introduce themselves, and then we are going to roll with the panel. We have a 30 minutes discussion followed by 10 minutes of Q&A. So our panelists for today are Richard Gonzalez. He's the founder and director for the IoT technology provider Sensor IT. Richard, if you can tell some things about you and what you're doing now, the projects that you're working on.
So, well, essentially Sensor IT is a technology provider. We design technology from the ground up, covering Internet of Things, IoT. So we start with the schematic, PCB, enclosure up until the end. So pretty much the entire value chain of IoT devices, hardware and software.
Thank you. Second panelist is Dr. Anna Maria Mandalari. She's assistant professor at UCL.
Hello, everyone. Welcome. I'm Anna Maria Mandalari, and my experience is about privacy and security for consumer Internet of Things. At the university, we set up the most advanced IoT testbed in the world, and we basically study what these consumer IoT devices are doing to your privacy and security.
And our third panelist is Ian Pearson. He's principal embedded solutions engineer at Microchip Technology.
Okay, so I'm Ian Pearson. I have spent the last 15, 18 years looking at networking, IP, wireless, more recently as it's come into security, and then more recently into FPGA. So I'm covering a whole gamut of solutions as far as hardware and design and all the things that go right and go wrong. So.
Thank you. Okay, let's kickstart this with a warm-up question about the current state of hardware security in the IoT space. So how would you describe this? Please feel free to go in which order.
Maybe I can start. Yeah. So when we first installed like more than 250 devices in our testbed, what we did as first things is we say, okay, let's see what they are doing with our data. So what is the status of security and privacy for these consumer IoT devices? In our testbed, we had like smart speakers, cameras, any kind of devices that you can buy in Amazon, for example. And we discovered that the majority of them, first of all, they use always the same hardware. So it's like the firmware is always the same. And this firmware has a lot of like security vulnerabilities. So it's very easy to do all kind of attacks to these devices. So we'd say that actually in the consumer space, at least, I don't know about the enterprises of industrial IoT devices, but in the consumer space, the state of security is very worrying.
So if you look at it from a perspective of building blocks for a design, then hardware security-wise, there are lots of things that are currently available. Okay, so you've got secure boot, you've got key provisioning and key storage, there are physically includable functions, there are lots and lots and lots of things on devices, but you have to use them correctly, and you have to put them on, and you have to want to put them on, and they have a cost, because these things don't come for free. And the more scaled you go in terms of how you put a device together and how you put hardware together to make it secure, then that adds complexity and adds cost, which is where it all starts becoming a bit more tricky. But hardware is but 1%, if you like, of the issue. As Anna's pointed out, the firmware has to run on it. I have to put that in correctly. If I don't know how the protocols work and I put insecurity and vulnerabilities in the protocol, I can have the most fantastic piece of hardware in the world that's got all the relevant pieces in whatsoever, but I've blown a hole in it elsewhere. So you have to look at this whole thing from not just hardware. It's a very, very, very important part of it, because that's the bit that's going to be remote. It's the bit that you've got no control over. You've got no control of anybody looking in. You have to try and think of all those things. So there's lots of things around hardware that have to be done to make hardware secure, no matter how many bits that the developers and manufacturers like ourselves have put in those devices. Okay.
So for me, I know there's a lot of options available there for hardware and software, both of them. What I do really have a problem, I always use the same analogy with cars. 40 years ago, everyone was trying a different thing with the cars. Audi was trying a different thing. BMW was trying a different thing. There was no framework around security or safety around cars in these guys. I think there should be something around IoT devices as well. There should be a framework. There should be a certification by which they needed to comply with that. So maybe me as a manufacturer, I'm doing something really, really bad, or maybe something really, really good. But the problem is some other manufacturers are not doing it. So I think there should be some kind of regulation, some kind of certification that will bring all of us to the same level. That's
that's interesting. That's coming. That's the critical bit. So there are frameworks. So IoTSF have done a framework that spawned itself into NIST and into the now just released EU Cyber, which is, if you've not read it, it's an interesting read of an evening, but it's very impactful, and it's something you're going to have to think about because it's heading for law. Okay, so things are going to become legislated, things are going to become required, and those frameworks for how you design hardware, how you put software together, how your data passages, how you've got data in transit, all the things that require security will quite quickly have an impact on what we do and how we think as developers. And so being aware of this is actually really important right now, because we're kind of almost at that knee point because government have woken up. They've realised there's a problem. And to your point, nobody does it the same way right now. And so those standards, those test methods will kick in as well, where actually there'll always be difference because everyone's going to do something differently, and every device needs to be done something subtly differently because it's about fitness for purpose. But those standards are going to be required. Those legislative requirements are coming in.
Yeah, in Europe there is also the Cybersecurity Act that is coming on in 2 years. The problem about the certificates, I think I'm absolutely pro certification, but the problem is about verification. So how you verify that actually they are complying with what they are these devices are certificating, right? So there is a problem of metrics, how to measure this. And who is doing that? It's like a standard organization, it's like third-party certificator. So there are all these discussions in place that are not clear yet. And the problem is that the legislation is coming. It's like in 2 years, that's nothing for manufacturers to be actually regulated. So this is a big, huge problem. I think it needs to be discussed more from the government.
Yeah, and equally, you've got to then look at do I need to put the same level of testing and certification against a consumer IoT device, which is doing something, let's call it something benign, just to be really, really benign as a temperature sensor in a house, okay, versus an industrial control system versus something military and aerospace. Sensor. So what am I testing against? Is there a level floor? Each one has got different requirements. So does it become by marketplace? And all these things at the moment are not ironed out even in the legislation. Okay, they kind of left it kind of open, but it will change. There's nothing more sure than it will change.
I had a question on the list that was addressing exactly these problems, because we are talking about hardware security and security in general, but actually how do we measure it? So are there criteria at the moment defined to measure the security, and how do we know that we are done with measuring it and that we are ready to deploy those devices and those solutions? I know it's an open question, open-ended question, but are there methodologies, are there tools at the moment in the community actually to do this?
There are some frameworks, but it's not clear what the legislation will be, how will evolve. So it's difficult actually to think now about some metrics or some general metrics. Also, as Ian said, like some metrics can be right from one manufacturer, but can be completely there are no general metrics. Mm-hmm. So when we talk about validation, I think this validation needs to be done by categories, at least categories of devices. You cannot have like a general verification system, I think.
Well, since I introduced the regulation, I think I'm gonna throw a spanner in the works right now. The problem I have with that is essentially that's going to be really expensive. So it depends how you're going to be testing, or whether you're going to be forced to test that. That could price us SMEs out of the market. It's as simple as that. So if you look at what happens with the CE marking, for instance, UKCA now, obviously, so Brexit, it's pretty much self-certification. That's it. So you just, thankfully it's not me, because that's my tone. Anyway, so if you certify yourself, obviously something that you're taking responsibility for your own product. I kind of like agree with that approach, but then it means that if for some reason you got something really, really naughty, you need to be punished big time. But at least you're taking responsibility for that, and that doesn't price us SMEs out of the market.
Wow, okay, yeah, there's about 15
it.
questions in one there going through my mind. Absolutely, there is a cost to it. I think if you read and it depends on market. So you can talk about the UK, or we talk about Europe, and we talk about the US, and we talk about other jurisdictions. They all have their own regulations. They all overlap and intermingle to some extent. And so ultimately, my end product is going to be sold here. I have to meet this regulation, and that's the decision you're making. So if you're making, you're an SME making for a small but very international market, absolutely, the potential is for it to be very onerous. So you're going to try and do the one that does the most, and therefore, do I come backwards and how do I certify? It's still a very complex problem to deal with. EU are basically looking at, well, it becomes part of RED. So if you want certification for your product, guess what? It's got to be cyber secure as well. And so nobody's going to like this, right? The fact is that we know looking across it that we're short of engineers, full stop, and then we're short of engineers in the cyber skill set, and SMEs can't afford to just go and hire 3 new guys to do cyber, because they're just not there to begin with, and they can't afford to. So they'll probably, and I'll take that off context, there will probably be some give and take in what gets done in legislation. I remember EMC kicking in and all the rules about that one 30 years ago. So there was an uproar then, and we got used to it. And so, yes, there's going to be challenges, absolutely. And then you come back to, when is my product ready to deploy?
Yes.
Well, okay. Am I a tick boxer? So I can say I've done all those and I've checked the boxes and I've passed the certification and I can get through the test. Or is it good enough because it protects my product and my name in the marketplace? Because that's ultimately what, if you've got a poor product, that will get pinned on the wall of the bad vendors, and then you'll lose market. So it's that bit of that becomes a problem as well. There's lots and lots of factors involved.
Also, like for manufacturer security, let's say by design or B certificate for security, it can be an advantage. Like think about a big player like Apple. They put privacy and security like a selling point.
Mm-hmm. They can afford it.
They can afford it, yeah. But you will like have advantage over your competitors.
Yeah, I know.
Yeah, I mean, right of today is that it's possible to make a secure product and it not be onerously more expensive than it is to make a unsecure connected product. Okay, the leap is not a huge leap forward. There's a mental leap to take, and there's a mindset leap to take of, I'm going to design this with security in mind, and that's the way in which our manufacturing goes. And there's lots of things around it, but component-wise, it's not like a factor of 10x more expensive, for instance. It's not that bad, but there is a heartfelt leap to be taken in. Actually, I have to design it from day one with that in mind.
Yeah, and actually it brings us to another question that I had on the list about, can the security team and the design team be the same team, or how they are going to work in order to deliver this security by design in the future?
But if you ask me, there's
Yeah.
absolutely no way it can be the same team. So
Okay.
it's pretty much the same with any approach in testing and development. So when you develop something and you test it, you can just tick on the box and for you, that's all
Definitely.
fine. Then someone gets in there and it just breaks the whole thing apart. So the testing team needs to be apart. Same applies to security.
Yeah.
Definitely.
Yeah, I absolutely. In the ideal world, no, brick walls, if you like, but there has to be a meeting of minds. They have to discuss it, but fox and the chicken coop kind of situation, isn't it? You can't have a test guy being the guy who wrote the software, because he's got instant bias. Okay, you can't do that, and you can't have the security guy being the guy who develops the code and goes, it's all right, I know what I meant. I really know what it's supposed to do.
Yeah.
It doesn't do it, but it's okay because I think I know what it's supposed
Why
to
would
do.
anyone do that?
Yeah.
I heard that without that.
Yeah, and so the challenge then comes back to the point. How's an SME going to deal with this? Because I can't now get a test team, a development team, a security team. It becomes hard. So there will always be an overlap to some extent, but that becomes how does the organisation deal with that? And that can be a design level problem. And how do I design to make sure that it's in place? Design to make sure that my, I've got the analysis done correctly and I know what the product's supposed to do and how am I going to adhere to that. And I'm doing testing as I go through to make sure that unit tests are working correctly. All those things that are getting taken out en route rather than going, right, I've got the product, it's supposed to ship tomorrow. Is it secure? Security? Or did we do that bit? Oh, damn it.
Yeah, this is why it's important to have like external framework for measuring security and helping like companies to compliance with these things.
Okay, so we keep talking about security, hardware, but we didn't talk actually about what are the threats that the hardware is exposed to. So what have you seen
in our taskmap we saw many things. Mostly like the problem with consumer, I'm talking about consumer IoT devices, is that they are produced by the same manufacturer, so different brands, they use same white label hardware. And the majority of this hardware is produced in other jurisdictions, like for example China or US, in which they have different regulations, so they don't do security by design at all. For example, so smart cameras were sent the traffic of the video and the date of the video completely unencrypted over the internet. Some other devices, they were activating the motion, for example, even if this was opted out in the app. So we saw this kind of threats that not only security threats, but also privacy threats for the user. And it's impossible for the consumer understanding what's going on in their home because they cannot see that the traffic is not encrypted.
Yeah, I agree. I think probably the main threat is those ones that are actually not even threats, that it's there, it's embedded into the design of the product. And there was this really notorious case of this camera that came from the Far East that had a hole that they put there in place so they could actually spy on you. So it's something that obviously is not a threat, it's not something someone hacked into it, it's just there by design. That's the main threat in my view.
Yeah, so two sides to this one.
Yeah.
Absolutely all the protocol threats, all of the lack of privacy controls, all of the lack of security all exist and they will continue to be there because there will always be software issues that need to be rectified. There will always be corners cut, that's unfortunately the way it is. But allowing for those, I've got this device that's remote. How do I actually store keys and make sure my device boots correctly? All those things on the part, and I can put the parts down on the board and I can do all the things I think are correct. But now, if you go through and look at the tools available now at, in reality, ridiculously low cost for what they do, to peel back those hardware layers and peel back that hardware security and get to secrets in the device, they all exist. So you've got to be very aware at design that bad actors, actually not even bad actors, just people who want your design or want to get into your system and see how it works, for instance. It'd just be IP theft, doesn't really necessarily be a bad actor trying to cause harm. They have infinite amount of time because you don't know they've opened your box. And they can get these tools and they can do all of those things. So you have to become very aware of that level of thing happening when you're doing a design now. So design is going to change subtly in that I'm going to not try and do it for least cost possible. I've got to do it for robustness and fitness for purpose, and get hold of these tools and become a student of them and become a student of what's failed in the past, and go, right, well, we know these things go wrong, let's look at how to get around it. Does the manufacturer provide me the ability to protect myself against some of that? What do I have to do at board level? What do I have to do at power supply, at board, at layout? There's all sorts of factors kick in that I've got to think about now. So yeah, it's going to become a little bit harder than it used to be. But that's unfortunately unfortunately or fortunately, where we're heading. Depends how you look at it.
And in your activity for more than 20 years, for all of us, have you seen or encountered any good technique actually to protect the hardware? Or are you working on something at the moment? Or do you see something coming out from big companies or chip producers?
Back to the first question. It's a constantly evolving process. So it's that game, isn't it? That, somebody breaks something, somebody finds a way to fix it, and it's going to keep going like that. You're going to deploy a piece of hardware, however, and you want it in the field for a period of time. So you've got to try and make that as future resilient as you possibly can, because once deployed, I can only do software updates, or I've got the cost to replace. Yeah, lots of things are happening in the realm of things changing on silicon. If you look around all the silicon vendors, not just ourselves, then newer techniques get put on board. There is ultimately a limitation to what you can do on silicon if you do the design badly in the first place at your level, and you don't handle keys correctly, and you don't look at it as an individual device, and you do something just crazy silly that opens up your whole infrastructure and your whole system because somebody's peeled back the hardware. So, yeah, specific things we're doing? No, can't talk about those.
Okay. Richard? maybe
For us,
or-
it's actually quite simple. This is what we were talking about before. And we use an approach that we call doorless house. The only way of ensuring that your house is not going to be marked is not having doors in it. So I know if you can afford it, they just do it that way, and that's what we do. I'm talking specifically about us in this case. I mean, we use monitoring devices. There's no need to have a holder. So there's only one-way traffic from the device to whatever the information is going to be sent through, and that's going to be just a piece of software there. So our hardware is completely opaque, so you can't get into it. If you can't get into it, unless you obviously physically break it, you need access to the device. If you get access to the device, I'm quite sure a lot of people will be able to crack it. But now, the way they are designed, in our case in particular, you can't get into the device. You can't get into the device, you can't crack it. Simple as that.
This is a very good solution for like devices that have that are used for monitoring, for example, but not for devices in which you need user interaction. So what we are doing at UCL, we implemented like a tool system that works on the home router. It's a software that basically check all the communication from your home and all the cloud services that these devices are contacting. And we believe that basically not all the communication that these devices are performing are essential for the device to work. And actually we saw that like more than 60% of these destinations can be blocked. So this is what we are doing. We do a sort of ad blocker for consumer IoT devices. And it's working fine. We are testing it. We are testing this with inter-service providers. So we are collaborating with BT, Telecom Italia in Italy, Telefonica in Spain. We are developing this tool, but it looks like it's working fine. So a solution maybe not directly protect the hardware, but protect or check basically the networking traffic for protecting the communication.
Thank you. I'm going to go back to something that was previously said about security and security by design and hardware security. Can we make it somehow a first-class constraint, or we can try, but we will never?
I think that goes back to my my consideration
Yes.
before, essentially
Yes.
just having some kind of like framework, but which need to comply with that kind of. It's the same with cars. I used that example before. I mean, they have to do it now. They didn't have to do it 40 years ago. They have to do it now. You wouldn't be able to sell a car that doesn't comply with that, and that. And that's pretty much what we need to head towards. We need to head towards having that kind of framework. And I'm not sure whether that's going to be something that you can self-certify. I wouldn't trust someone certifying the security in a product. But again, it needs to be something in the middle that I can't just like get rid of all the SMEs, because they're pretty much the people that are producing all the technology at this point in time. But I think the end point needs to be that there needs to be certification. Unless you comply with that framework, you shouldn't be able to sell any product. And I'm going a little bit further than that. I mean, not just about security, even functionality as well.
Oh, yeah.
If I buy an Alexa, which I wouldn't buy in my entire life, but anyway, up to anyone, I need to know what kind of data that thing's transmitting from my house. I need some kind of like paper that says that, well, this is going to be listening all the time. You should know that. Not just about hacking. It's about what is this thing doing really with my data? Where is it going? And that needs to be on paper. And if for some reason I find out that this guy's actually taking photos of me, then I should be able to go to court and just like, is that a cool case?
Yeah, so this kind of technology already exists, but the problem is called MUD profile, manufacturer user descriptor, but this one is an IATF standard of some years ago. The problem is that no manufacturers are using it. So until there won't be like a sort of certificate or legislation of like real verificator that verify what actually they are declaring, this can be completely useless. But there is a standard. It's called MUD profile.
So I guess back to the question, can we make it
First
first
class.
class? Well,
Should we even make
we can, but we have to want to.
this?
We can because we're going to be forced to by legislation. And actually, is it a good thing? Well, if we discuss some of the things going on, then yes, actually, it's necessary. But you have to want to do it, and you have to change your mindset to do it. So it's not a case of dragging yourself to be forced to do security. It's kind of, it's actually really exciting, folks. I mean, don't think of it as a bad thing. It's actually quite interesting to do it. But it is, you know, you've got to want to do it. You've got to get yourself into that frame of, right, I have to design differently. I'm going to have to do this and approach it differently. And I have to do it at the beginning. And before that, I've got to think about what we're trying to do and why, and what's the end goal, and what do I have to meet. And I have to do things like threat modeling. And I have to do other techniques around just putting a PCB together. Because it's not that anymore. The PCB is one part of a much, much bigger cycle of things that have to go on. And the other critical thing is, it never stops. Once I've deployed it, this never stops. Because I will get a vulnerability, hence I have to have firmware updates in the legislation. So I have to keep managing that. I have to design with that in mind, and so it becomes a problem I'm going to have to deal with for as long as the product exists, or as long as we declare its lifetime is. Let's get the legislation right. Yeah. And there'll be an expectation based on where it goes in certain markets and certain levels of support. And you know, my threat model will constantly evolve because new things will happen in the marketplace. You will get vulnerabilities because folks will find them in a lab and go, guys, you know, you might want to fix this. And all these things have to be factored in. So there is a sort of a shift that needs to happen for us to accept that that's where we've got to get to for this to work. But we're going to get arguably dragged kicking and screaming whether we like it or not. So.
And another point for motivating manufacturers on like adopting security will be like making the users aware of what's happening in the smart home, for example. So collaborating with the data protection authorities, do sensitive materials of what happened when you are profiled by these devices, for example. So this is also important. So it's like a cooperation between standard organization, universities, data protection authorities, and manufacturers.
Thank you. I'm going to end the panel with my last question, and then we open the floor for the audience to ask questions. So, are there any myths that you would like to dispel when it comes to hardware security and IoT security in general? Anything from your experience?
I'm going to go for the top one. It's when people think you're not important enough, yes, you are for them. People think, no, well, it's just a small company, this is a sensor, doesn't do anything, it's never going to get hacked into it. But you are.
Thank you. Thank you, Richard.
One thing that I really hate is when they say, I have a VPN, I'm safe. This is really something, I really hate this. Because basically we discussed like the threats come from internal to your smart home. So having a VPN really doesn't save you.
Thank you.
You're safe to the VPN exit point and the provider, yeah. There's no magic silver bullet on this one. It's not a case of if I put this down, it's all fixed. Okay, this is now it's a big, to use that word, it's a big holistic problem you've got to deal with, which is looking at the threat environment you're going to be into, what the product does, what's the appropriate level of threat for that part. The parts are now becoming relatively standardized in security as to what's available, but you still have to implement it correctly. And so, you know, you just have to kind of force yourself over the threshold, if you like, and look at what's happening, look at how to do that design. The design practices are around, they are out there, but there's certainly resistance to go to them, I think, at the moment, because there's no requirement. But no, there's nothing magic that we can say, and it's which makes the point. Look, that benign little sensor on the wall could be the one thing the guy needs to get into the network in the building you're in. So everything on the network becomes important. Every element of that security becomes important. How you section it out, how you isolate things within its infrastructure and within its setup, how I isolate keys. Crucially is things like, the biggest one would be ensuring that you don't do something that allows you to have an at-scale vulnerability, so that you put the same key in every device and ship it. So once they've got that key, every single unit of yours is now vulnerable. That's a big problem to solve. So resolving that is probably one of the first things to do, is to think about this as, what happens if I get an at-scale attack? Okay, because you don't want to be working the weekends. Okay.
Thank you. So we are opening for a question from the audience now, please.
Hello, can you hear me? Yes. My name is Georgios. I would like to ask Richard 2 questions actually. How do you make a hardware device doorless? Do you mean something that requires a chainsaw to open, for example?
No. What I mean by that, it's essentially doesn't have any ways of accessing that piece of hardware. So communication only happens in one way, direction. That's it. So if this is the sensor, it's just sending data, and there's a receiver end that is just getting data from that sensor. So if you're sending data only, there's no way you can connect to that device and opening a security hole with that device.
Okay, got it, thanks. The other question is, if you have any specific resources on how to design for security, as opposed to just Googling.
So say it again, repeat that.
If you have any specific resources in mind for designing for security.
You have some
Like a book.
guidelines.
Yeah, like
For
a
example,
website, a book or
NIST.
something.
Yeah, NIST guidelines, which are like the US Organization for Security. That one, they put some guidelines of like how to design IoT devices security. There is the one from the UK government. That was from 2018, I think.
Quite old.
Yeah.
Okay, thank you.
And I'll add to that one is some that have been around for a few years and keep getting updated, and I'm getting the nod from John at the front to just remind me of it. So the IoT Security Foundation, which is a UK organisation of basically interested minds from industry that have created it, rather than it being government doing it the opposite way around. They have a great set of guidelines in there, and again, you marry those with what NIST do and with what's coming out. Googling security could be quite random. There's different things on different manufacturer websites as to how to achieve it. Lots of things, if you look at if you go and look at things like Black Hat, okay, on YouTube. Okay, so Black Hat is a hacking website, or hacking organisation, ethical security organisation, should I say. But they will have examples on there, and again, outfits like DEF CON, okay. So it's a big hackers thing in the US that happens every year. They do phenomenal talks about how to look at designing hardware. They're telling you how they got in, just reverse the thought and go, right, how did they get in, what did they do? Okay, what do I need to think about now to not be vulnerable to that effect? And there's actually a good couple of books that are around now from some of the guys who do those talks and make some of the tools that are available. So there is lots of resource out there, but there isn't a design that says, do this, so you'll be fine, okay? Because you're going to do something different to what something says on there, and every design is subtly different. Okay, so you've got to apply available knowledge, really. Okay, does that help?
Thank you.
Hi, thanks for a great talk. I just have one question, which is probably more for Anna. Do you guys have a way of classifying the level of breach or the level of hack that happens on a device? You say like 150 devices on the bench, but are they just different packets, or are you getting into the system, being able to upload data to AWS, disrupt the network, things and pieces like that?
So what we are doing, we also built like a framework for testing the security of these devices. So we generate attacks, like Mirai attacks or DOS attacks and stuff like that. And we see how, for example, weak passwords, stuff like this. And we actually see how these devices react to this. So yes, we built a system not only for sniffing packets and understanding which traffic is non-essential or not, but also like testing against like well-known consumer IoT devices security attacks.
Okay, so you just try to get in, you're not trying to see how much you can then exploit once you are inside that device. Because again, like sniffing a packet and maybe seeing someone's temperature data is not exactly the end of the world, whereas me making a botnet and sending a ton of data up to someone's AWS is going to cost them thousands of pounds.
Yeah. We didn't notice this basically behavior in any of the devices that we have.
Okay, cool, thank you.
Yeah, welcome.
Thank you. There was a question from behind.
Thank you, and thank you for a great talk. My question is, if I did a parallel to the financial world, where there's a massive information asymmetry between providers and consumers, and I think the same thing happens within the technology. There's a huge information asymmetry. So given that, what are your views on implementing a much stronger regulatory body, such as we have in financial services?
Wow. Viewpoint. Okay. Let's close that one off. I'd say some of it is starting to arrive. Okay, it's not apparent because there's not as much money involved, right? And there's not as much emotion involved. And if you look at the way people give data away right now without caring one iota, take your phone out, just think how much you've given away sat in the room, okay? Everybody's left their Bluetooth on, okay? Put the scanner on. We'll see who's... Yeah, I did it upstairs, and there's thousands sitting there with their Bluetooth on. I can say I've got mine's on, okay? So people unknowingly give it away and wittingly just to sign off to give people data. And as you pointed out, you know, it's going to go to AWS off an Alexa. Well, I signed because I said I'd use it, but I never read the terms and conditions because they're too damn difficult to understand. And so I think with what's happening with certainly EU cyber, when you read into it, and with what's coming on the PSTI bill in the UK, things will certainly start heading in that direction, and the onus will be on companies to prove certain aspects of how they're securing your data, if nothing else. Other things in the GDPR and the equivalent start to look at the privacy of how they use it afterwards, because that's a different thing. But yeah, it's there's not as much emotion about it yet. Right. Governments don't have to care because it's not banking money, right? Because they're not liable for anything. Okay.
Yeah, maybe it's gonna be easier, like, to give users tools for monitoring these things instead of like putting like a big entity on top of everything. Like, for example, a simple app in which you can visualize easily where the traffic from your devices is going. And then you decide what to do with the device, destroyed it or put it out.
Well, in my case, I mean, this is going to define me. I'm all for it. I hope it doesn't happen. Because I know what's going to happen. It's going to be full of regulation, full of things that we, small companies, are not going to be able to comply with. It's going to cost us a fortune, yes. And it will be to a point in which we have to fold, as simple as that. That's what I think is going to happen, but I think it's the only solution. So it's a bit of an irony here.
Yeah, I just add one that came in from some of the comments made, which is this bit of it to some extent, it's about people caring right now. Most people, like I say, we willingly give data away, and we don't care about it until it bites us. But we don't know how much you've given away, and you don't know how much you've been targeted, and everybody gets annoyed by the phone calls and the spam email and everything else. But we've given that data away, we just don't know where to. And so I think it's Germany was looking at something similar where, you know, you are in control of what you own that data. That data is mine, not yours. And that's maybe where the inflection would come, but I probably think we're a while away from those things happening yet. So.
Thank you. Any other questions from the audience? If not, let's thank the panelists. Thank you very much.